So section 2.2 is going to give us some experience working with functions, in particular their graphs, and more than is expected of you in like an intermediate algebra class, we're going to start asking you to draw some pretty decent graphs. I mean, not just whatever comes out of the calculator. Now it's going to start with some examples from section 2.2 in terms of graphing, and I guess the first thing I want to do is remind you how you're going to set up a table on your graphing calculator. So we'll go through that. We'll also go through what the graph should look like when you enter it into WebAssign. If you wanted to scan the QR code, you can get to a nice Desmos link. If not, that's okay too. But let's start with this one on the graphing calculator. F of x equals x minus 7 over 2. So if I'm going to graph that, it's going to be a piecewise graph. Let me shut off some of the other stuff that I have going here. So I'll shut off these two graphs. And that's kind of a nice trick. If you want to keep an equation but not necessarily graph it, then what you can do is deselect the equation in the equation editor. So for right now, I want to graph x minus 7 over 2, so I'll press the enter key. And so when I go around to graph this, it'll come up for me. Now this one I haven't selected, but it's equivalent, and I want to show you how to do this one just in case that you'd like to remember that. It's a little bit more user-friendly than putting things in this way. So if you want to put it in a nice horizontal fraction like I did, and not necessarily have to worry about the parentheses, then where you're going to go to is the alpha key, then the y equals key. The first option here allows you to input kind of a regular numerator denominator type fraction. So just type the number 1. That gives you a nice numerator denominator. We'll type in x minus 7. Now you don't have to do both of them. I am going to show you both of these and show you the difference that you'll get in the output. You only have to do one. So whichever one you want, that's fine. Let's double check your window settings or your table settings. To do that, hit the second key, then the window key. And the two settings that I'm concerned about are for independent and dependent. Should be set to ask and auto respectively. If they're not, just go down, cursor to whatever, and then press enter over the appropriate spot. When we got that, then we can set up our table, or we can run our table. Now what we're being asked for is to evaluate this function for these 6 numbers, 0 through 5. Okay, let's go back here. Second key, then the table, and you can just type in those values. Now if you have some other values there, you can just hit the delete key, get rid of those, and then just type in the values that you want. 0, 1, 2, 3, 4, and 5. Now you may notice that I've got 2 columns here. They're both the same. They're both equivalent, I should say. So negative 7 halves, negative 3.5, they have the same value. The difference is this is coming from the one that I set up with a fraction. This is just the one that I did with x minus 7 divided by 2 with that /. So nice. So we can fill in those values into our table here. Let's do that. So it was negative 3.5, negative 3, negative 2.5, negative 2, negative 1.5, and negative 1. Yay. So the next part of this is they are going to ask you to graph this on WebAssign. Now, in case you kind of missed it, and it is somewhat small or faint on your handout, there is a restriction on this. They only want you to look at values of x between 0 and 5. So, okay, we can do that. That's this stuff right here. And because we're restricting our graph to be between 0 and 5, we're also going to restrict what we draw on WebAssign. So here's the point. 0, negative 3.5. Here's the point 5, negative 1. I want to draw everything in between those. So like that. So in WebAssign, don't draw something that goes to infinity in either direction. You just want to draw a little line segment between those 2 points. Cool. And that's it. So just a reminder of some calculator skills, and you should be good. Now, if you wanted to graph this, if you wanted to see, all right, well, what does this look like? Then let me show you what you can do on your graphing calculator as kind of a little trick to restrict your graph to just the little part that you need. So what I'm going to do is I'm going to set up my window to be between 0 and 5. So just the values of x that I absolutely need. A good question would be, well, what y values do I use? Well, okay, that's a good question. You could plug in values into a table and figure out the y values you need, or you could let your graphing calculator do this. You could let your graphing calculator do your thinking for you. So to do that, you're going to hit the zoom key, and you want zoom fit. And that happens to be zoom 0. That'll fit your window in the y direction to the values of x, or the values of y you get from your values of x that you chose. So zoom and then 0, and it gives you something like that. Now, this isn't exactly ideal, but it gives you a good starting place, and you can kind of make adjustments from there. For instance, maybe you want to see the graph, maybe you want to see the x-axis. So let's go up to, say, y equals 1. And maybe you want to see the graph a little bit below where it is, so negative 4 to 1. And now we hit the graph key, and all right, at least showing the x-axis helps you orient yourself a little bit more. You can see a little bit about, oh yeah, this is below the x-axis, that kind of thing. It's up to you. Later on, we'll play around with the tick marks here, so we can discuss that. But for now, I think that's pretty good. If you kind of a little shortcut you can use here to figure out, well, where is this happening? Where is this happening? If you hit the trace key and trace, say, x equals 0, now you're not going to see anything on the bottom until you actually type a number. But if you trace a 0, it says, oh, at x equals 0, you're at negative 3.5. Let's type in another number. Type in an x equals 5. At x equals 5, you're at negative 1. So you can get a lot out of your graphs here. So I threw a lot at you. If I went a little too fast with some of that, let me know. Is there something you want me to review in all those little tricks and commands? Was there one that you found that you liked? Hetty, what you got?
The zoom. Could you do that again?
Yeah, so it's zoom fit. So once you set your values of x in the x direction, zoom fit will adjust your calculator to be perfectly fit in the y direction. So zoom, you can just type in the 0. I'll scroll down so you can actually see it. There's your zoom fit. But you can just type zoom 0, and that's going to resize my window so that it just barely fits my graph. So I'll press enter here, and then you'll see, yeah, that the graph just barely fits. Okay? So it's a good one. It doesn't necessarily need to be your last stop in doing these kind of things, but it is a good one along the way. Okay, let's take a look at the next one down. So example B. Now oh, all right, I'm sorry. Let me just check here, my settings. Thanks, Robert. Zoom. How's that? Can you see it? See it now? See the graphing calculator now? Yeah, thank you. Okay. All right, so let's take a look at the next one down. Now the next one down, they don't actually give you the equation here, but I'm pretty sure it's gonna be y equals x squared plus 10. Not that it necessarily matters for us, but I want us to look through at this and be critical of the graphs. If you were me and you're looking at this, what would you have to say about each of these graphs? Let's start with the one in the upper left-hand corner. Now overall, because there's an x squared term in here, you expect the shape of a parabola, right? So, I mean, that's something that you've been ingrained with for a long time. This isn't bad, but there's something there that's kind of missing that a lot of people would feel better about having on their graph. What is it?
An x value.
Yeah, the x-axis, right? So we can't see the x-axis, and it makes me feel a little bit lost. It's like, well, where is it? How high up is this? So this one's missing the x-axis. So, all right, that's kind of a bummer. Not so good there. This one reminds me of some pictures that some of my family take. And I guess I'm particularly sensitive to this because my dad used to be in photography, used to teach photography here at OCC, in fact. It's kind of cool. But this reminds me of some of those family pictures that I used to see in the following sense. Not that a parabola looks like any of my family. There's no resemblance there. But what I'm talking about is how small this is compared to the rest of the graph, right? Do you ever see those pictures that, you know, the person is like really, really tiny in this huge background? It's like, oh, you wasted a lot of space here. You could have zoomed in, you know, take a few steps in. That's what's wrong with this one. You know, you're wasting a lot of space. Most of this graph, most of this picture is just wasted space. So too much wasted space. How about this one down here? Is anything wrong with that one? It's got the x-axis.
Can't really see the whole curve.
Yeah, it doesn't even look like a parabola, right? I mean, it's supposed to be a parabola, but it doesn't really look like one. So, yeah, you're zoomed in too much. So, it doesn't look like a parabola. What do you think about the last one?
Perfect.
Yeah, that one's the Goldilocks one. Just right. You know, not too hard, not too soft, just right. Yeah, that one's looking pretty good. So, you know, that's just kind of a rough pass at some of the things that you can see when you're graphing these kinds of problems. Now, let's take a look at another set of equations, and this time I want you to graph them on your graphing calculator, and that's on the flip side here. The equation that we're going to deal with, or the graph that we're going to deal with, is 8x minus x squared. So I'm going to go to my graphing calculator and
Thank you.
shut this off. Let's clear out some of this old stuff. Shut off one of my old graphs and turn on this one. So let's shut off these graphs. Now you can just clear them out if you have some other stuff in here. You don't have to save them. So I can just hit the clear key to get rid of those. And to turn on this graph, since I already have it programmed in, I'll just press the enter key with the cursor over the equals. So, nice. But now they asked us to evaluate the graph in 5 different places, 5 different sets of windows. So let me share with you how those windows work. Let's see here. So the way these work is this. And let's get to the right window here. There we go. So they're giving you -5 to 5 by -5 to 5. What they're giving you are the X-min, the X-max, the Y-min, and the Y-max. So those are the window settings that you're going to need to pick up from this. And let's try these. So let me zoom out a little bit. So you're going to go to Window. Make sure that when you type in -5 that you use the opposite key on the bottom row of your calculator, not the subtraction key. It'll give you an error if you don't. And then on the y-axis, -5 to 5 again. Then you take a look at the graph. I'm going to make y scale equal to 1. I'll go back and change that again later. What do you think of the graph here? What kind of shape are you expecting from this one anyways? Does that look like it? No, it doesn't look so good. It looks kind of like a straight line almost, really. But you should be expecting a parabola. In fact, if you remember your intermediate algebra pretty well, you could expect a parabola that faces which way?
Down.
Down, yeah. Thank you, Julian. Faces down. All right, let's take a look at this next one, -10 to 10. Now I'll give you a quick way to get those settings. So if you want to graph yours from -10 to 10, that's what's called the standard window. So you can hit zoom and then standard, which is zoom 6. That'll set your calculator's window to be from -10 to 10 on both the X and Y axis. Okay, so a little better. What's wrong with this one? Yeah, nice. Yeah, it cuts off the vertex. So not really our favorite one there. Let's try the next one. So next one is -2 to 10. -2 to 10. And then -5 to 20. What do you think of this one?
Perfect.
It's looking a lot better. Now, there is one thing that I want us to change and become a little bit familiar with. It's looking a little crowded here on the y-axis, isn't it? If I ask you how high this is here, you'd be making yourself dizzy trying to count all these little tick marks. So let's go back to our window key, and we're going to adjust what's called the Y scale. So I'm going to make Y scale equal to 5, and then regraph it. What's happening on the y-axis now?
Spread out.
Yeah, more spread out. But what you got to remember is that each tick mark now represents a unit of 5. So this is 5, 10, 15. So the maximum here for this function, it's a little bit over 15, maybe 16. You can figure that out if you wanted to hit the trace key. If you trace when x equals 4, there you go, 16. So, nice. And of course you can zoom around a little bit as much as you want, or type in a nice number like 6, etc. And when you type in a number, you're going to get back the x and y coordinates for that number. Okay, so that's a pretty good graph right there. So far, I think that one's the best. Let's take a look at one last one here. And for that one, we're going to set up our window to be -10 to 10 on the x-axis and -100 to 200 on the y-axis. And this graph's going to have a couple things that I would object to. Maybe 2 or 3. What do you see? What about this graph is kind of like, meh, bothers you? If you wanted to be picky on somebody, what would you complain about here?
Y-axis.
Yeah, the y-axis is kind of a mess, right? Because you got tick marks. I left it at every 5, so the y-axis is pretty crowded. There's a lot of things going on there. So I would probably change the y scale to clean that up. What else is maybe not ideal about this graph?
In the bottom corner, and you can't really see like the whole horizon.
I couldn't quite hear all that.
It's in like the bottom corner, you can't really see the whole, so that whole thing.
Yeah, exactly. So there's a lot of wasted space up here, right? I mean, more than half of our screen is just blank. So probably want to shift that graph up considerably, and then maybe shift it over a little bit to the right as well, all right? Because it's not nice and neatly centered across the vertex. So yeah, there's a lot of things that are messed up about this, not the least of which is all the space you're wasting on the y-axis or in the y direction. So nice. So let's just waste a lot of space. Waste a lot of space, amongst other complaints. This one, that one was pretty good. This is too small. Can't even tell it was a parabola from that one. All right, so let's move on down to working with piecewise functions. Piecewise functions. Now these are functions that you can run into here and there. Interestingly enough, the speed of sound, how fast sound travels through air, is a piecewise function because it varies with your altitude. The higher you go, the more it's going to change. And I think when Chuck Yeager first broke the speed of sound in a jet, probably in like the 50s or so, he had to fly at the right altitude, so the speed of sound was slow enough for him to exceed it. In any case, let's look at this one. This is a graph of a piecewise function. It's really the combination of 2 different graphs. So it's a combination of the graph of y equals 0 is part of it, and then y equals 1 is another part. What does a graph of y equals 0 look like, or what's a graph of y equals 1 look like? Does anyone know? Yeah, they're both straight lines. They're nice horizontal lines. So now the thing is, we're going to make a restriction on this so that I only want to graph the line y equals 0 up to the point where x equals 5.
Tired this one.
Off the rim. All right. So this graph is going to be y equals 0 up to this point, not including 5. After 5, we're going to graph y equals 1 to the right. And we'll put a solid dot there because we're including what's happening at the end point. Now, a good question is, well, okay, how are we going to get our technology to graph that? I mean, this one wasn't too particularly hard, but it'd be nice to get our technology to graph that. So I'll show you how to do this on both Desmos and the graphing calculator. If you're going to pick one to learn, I'd make sure you learn how to do it on the graphing calculator, so that way in the next course, when you're taking trigonometry or calculus, that you know how to do it there. I wouldn't necessarily count on your instructor allowing you to use Desmos, although we will. So let me go back to my graphing calculator and clear out a bunch of stuff. So clear that out. I'm going to squeeze this in right here. I want to graph y equals 0 and y equals 1. Those are the two functions I want to graph. I'll clear out this one as well. But if I just hit the enter key right now, I'm just going to get like kind of everything. I don't really want that right now. Let me adjust my window, and I'll do it the cheating way. I'll do zoom standard. Zoom 6. There you go. You can't even see my second graph because it's right on the x-axis. But that's not really what I want. So I'm going to make a couple adjustments here. I only want this graph for values of x that are what? Which values of x do I want?
Less than 5.
I think it's less than 5, yeah. So here's a pro tip, and maybe I'll try and explain this a little bit, but we need to put in the condition that x has to be less than 5. So let's put a division here, divide by, and then put in that condition that x has to be less than 5. So divide by, and then a left parenthesis, x, but, well, where's the less than sign on this calculator? Well, that's why you guys are paying me the big bucks, because I know this calculator inside and out. You're going to hit the second key, then the test key, and there you go. Option number 5, that's your less than. So x is less than 5, and then right parenthesis. You know, I'm going to also change the color of my graph. Did you guys know you can do that? So if you cursor over here to the left and move things around, yeah, you know, I'm going to stick with magenta. There. And then press OK. All right, so that's one part of the graph. And let's see what that does. There you go. So you see that magenta graph, y equals 0, up to the point that you get to 5. Now I need to change things for the other part of the graph. So let me do that as well. Let's go back down here to the 1. When you put in your condition, I strongly suggest you do a divided by here. So we'll do a divide by and left parenthesis. Our condition here is that x is greater than or equal to 1. So type in the x. Where do I find all those logical operators? The less than or equal to?
Second test.
Second test. Well done. So this time I want to make sure that x is greater than or equal to 5. So I'll type in a 4 here, and then a 5. I can adjust my window a little bit if I wanted to, but there it is. Let's go back and adjust the window a little bit. I don't think I need to graph this all the way down to -10 or up to 10. Let me go from -1 to 2. That's a little bit better. So there you go. So it's called a step function. You're going from one level, then you step up to the next level. There you go. There's your step function. How are we looking with that one? You guys okay? We're going to practice that again with our next function. So with our next function, we've got this here, 2x plus 6 for x less than 1, excuse me, x less than -1, and 6 minus x for x greater than or equal to -1. So again, you want to go back, plug everything in. Let me clear out some stuff. I keep track of my keystrokes so you can kind of follow along. I've already got this one entered. For me, I've got it entered in Y6 and Y7. What I'm going to do is walk around and make sure that you guys are able to put this in. as far as the window is concerned, I'm gonna change the window to somewhat closer match the graph that's on your handout. So I'm gonna set it up between -8 and 8 on the x-axis, and then press that wonderful zoom 0 key. And see how we go from there. But I'm gonna walk around and make sure that everyone's able to get these graphs.
Do you have any more calculators here?
I do.
Appreciate it.
Yeah, no worries. So you probably want to hit zoom 0. And that'll fit things a little bit better. See this plot up here? When you press the enter key, it's going to give you an error. So you want to go up here, press enter to get rid of that. Let's go to the top. Press enter to get rid of that, shut it off. And now when you try to graph it, you won't get an error.
Restart, he said.
No, you don't have to restart
No,
it.
he said.
No, you just keep typing, you just don't want to graph that part of it. Good man. So you didn't need to spend that extra $100.
Yeah.
Alright, yeah, I don't know how to do the Inspire so well. I got a friend that knows how to do it. If you can't figure it out, let me know, I can ask him.
Yeah, I was having issues, I couldn't get it to.
You try Googling it. I mean, Google knows like everything, right? Okay, alright, that's fine, that's fine. Looking good. You might want to shut out these. So you can just press enter here, enter here. Shut out those, you don't get all those graphs. Yeah. So one way to show it right. If you hit the second key with the right arrow, it'll take you all the way back. I don't know how to do those. Yeah, I would bet you it's on YouTube. Yeah, I don't know how to use those. If you want to borrow one of mine, just, know the drill.
I have a question too. Is the window setting reset every time you put in a function?
No, it'll stay there until you change it. So if you do like -8 to 8, and then zoom 0, then it'll reset the window in the y direction. But, looks like you got it. Good, good. All right. Okay, so I'm going to shut off my graphs up here. Let's see, enter and then enter. No, up. Set up my window between -8 and 8. And then zoom 0. Okay, not so bad. Maybe you want to see a little bit higher than this. So you can go up to Y max and make that a little bit bigger. Let's make it maybe 8. And then take a look at the graph. That's a little bit better. It's in my comfort zone to see above and below my graph. So I'm feeling good about that one. All right, there's one more like these that we got to do. Questions on this one before I show you the last little trick here with these kinds of things? So, yeah.
I'm sure we can check this one.
Yes. You're using the subtraction key to type in your negatives. You need to use the opposite key on the bottom of your calculator. All right. So the last one is a good one, and I'm glad that I included this here because there's a little trick when you enter this into your graphing calculator. And that little trick is, for this middle condition, you can't type it in just like you see it. Texas Instrument graphing calculator won't understand what you're talking about. It'll interpret it differently and it'll mess you up. You've got to type it in 2 installments, and both of those need to be in a set of parentheses. So you're going to need a double set of parentheses. Parentheses around each condition and parentheses around the whole thing. And that whole thing is still going to be underneath the division sign. So you're going to divide by that condition. So let's see about entering that one. So I'll come back here, y equals, and I think I can clear out a bunch of this old stuff. So let me clear out that, that, and that. And let's see, do I have anything else? No. All right. So there's three parts of this. The first part is 4 divided by parentheses x is less than 2, excuse me, less than -2. Second test, 5, -2. Then what? X squared between -2 and 2. Now this is the one we've got to enter in kind of carefully. X squared divided by 2 sets of parentheses. The first one is -2 is less than x, excuse me, less than or equal to x. So second test, 6 less than or equal to x. And let me clear out this because it's getting kind of messy. Yes, I want to clear that. Parentheses, x less than or equal to 2. So back to second test again. And again, 6. Oops. Less than or equal to 2. And then 2 sets of parentheses. So that middle condition is kind of a pain. Not much I can do about it. Finally, the last condition, we need to type in negative x plus 6 parentheses divided by x is greater than 2. So that condition, x is greater than 2. Okay. We've got to figure out a window for this to graph. I'm just going to say, let's go with -4 to 4. You know, nothing big there. So window, -4 to 4 on the x-axis. And let me show you the downside of, it's not a big downside, it's a little downside of using the zoom fit. Maybe you can spot it. So zoom fit, that was zoom and then what number?
0.
0. So zoom 0. Zoom 0. Bam. Okay, so it fitted pretty nicely. But there is one little thing that I don't really like about this graph. Can anyone tell me what that would be? Yes?
It's focused on just the parabola and not the rest of the function. Is there any zoom in just the center?
Yeah, so it's got the parabola pretty nicely, but for instance over here, you can't really see all of this. It just makes me feel a little uncomfortable that it's stuck right at the top. I don't like that. So what I can do is I can just make it a little taller. So I'll change Y max. And that looks a little better. I can see the top of the graph now. I can see over the graph and see that there's nothing above. And I just feel better about that graph as opposed to the previous one. So in any case, the big thing to focus in on is how you do this part right here. It has to be with a double inequality. That stuff does get easier if you're working on Desmos. I'll show you that in a little bit. But for now, let me just try and explain a little bit about what's going on with this inequality where I say, well, you want to divide by that. So what's going on here is when you've got this condition, x is less than -2, it's either going to have a value of 1 if it's true, or 0 if it's false. Now, if I go back down here and put in, just say, if I just put in a times here, or if I just leave that, then watch what happens to the graph. I wouldn't suggest you necessarily do this. I mean, you can if you want to experiment with it. But take a look what happened. Your graph is up here, but suddenly it's also down here. Because for a while this condition is true, to the left of -2, yeah, you're multiplying by 1, so you get the graph. But then when the condition is false, you multiply by 0, and that's why the graph is down here. But we don't want that part of it, do we? I don't want to see that. And so the pro tip that I gave you was to put in a division. Now, why does that work so well? Well, when the graph is someplace you don't want to see it, this condition is a 0. What happens when you divide by 0? It's undefined, right? So your graphing calculator wants to graph it, but it can't because it's not defined. So when I take and put that divide back in there, I only get the graph that I want. So that's why that divide by trick works pretty well. It just limits you to the graph that you want. And here you need parentheses around this, because if you didn't have that extra set of parentheses, you'd be divided by the first condition but multiplying by the second one. You want to divide by the whole thing. So a little insight into what's going on with that. All right, one last one from this section, and it's example D. How about my homers? You guys doing okay there? Give me a thumbs up. All right, thank you. Let's take a look at example D. And scroll down here. So it gives us the graph of this piecewise function. -5 for x less than -1, 3 for x between -1 and 1, and -5 for x greater than 1. Now, I guess what I should focus on, or what I would focus in on for you, is this part right here. This middle part should be a flat line at what height? When x is between -1 and 1, where should the graph be? One more time?
0.
3, at 3, right? So the graph should be up here at 3, here to here. But neither of these first two are at 3. So we can eliminate those. Your job in here is to pick which one is right. I can eliminate that one, and I can eliminate that one. Neither of these are correct. Looking back then again, both of these are at the correct height. Correct height of 3, and then outside of the interval -1 to 1, you're at a height of -5. So both of these graphs seem like they work. But one of them's close, one of them's exact. So I'll call this one number 1, this one number 2. And I'll give you a couple minutes, well, not a couple minutes, I'll give you a few seconds to look at these and try and decide which one is which. And I'll ask you all to tell me the same answer at the same time. So, did you have the right answer? Okay, all right. Well, you can just participate with everyone else then. But decide, and hold up, one finger or two. People at home, you can throw a number in the chat, throw it to me privately, or throw it to everyone, doesn't matter. All right. So, ready, fire, aim. 1, 2, 3. Let's see them. All right. Yeah, that seemed like I'm not sure, but the rest of you guys seem pretty unanimous in this one. It's number 1. Why number 1 and why not number 2? What's the difference between these? What should I be paying attention to? Hattie?
The open and closed circles.
Bingo, well done. The open and closed circles. We want to include the endpoints at a -1 and 1 for this part of the function. So that's your closed circle. As opposed to this has an open circle. So this one's close, but it's not quite there. So pay attention to that kind of stuff. Those are the little ticky-tack points that take you down from an A to a B, right? You keep on losing these kind of things. So be careful with those. Any other comments or questions on graphing here? All right. Well, I think that'll do it for section 2.2.